More reactions. These are really good. This is my favorite reaction. Well, one of them. I have way too many favorite reactions. But MCPBA stands for metachloroperbenzoic acid. And the reason I like this reaction, it was the very first reaction I carried out in a lab. This is the solvent. This is dichloromethane. And when you use MCPBA, what's going to happen is that you're going to add an oxygen across the double bond. And just one oxygen we're adding. So we're going to add it, forming a three-member ring. Now the three-member ring is what it's called an epoxide. Some people call it an oxirane, but whichever name you want to use, it's a three-member ring. And in a three-member ring, there's a lot of angle strain. So usually we make the epoxide and then we have a nucleophile attack the epoxide and pop it open. So that's one of the reactions that we're going to do after you make the epoxide. Now these two reactions are important. Notice that it's a bromination reaction. It all depends on the solvents that we're using. This one right here is chloroform. But when you use a halogenated solvent, we're going to add the two halides across the double bond. So one halite's going to go to one carbon and the other halide to the other. And it's going to be an anti-addition. So when you do an anti-addition, make sure that you put a bromide on one carbon. And the other one, the second one, goes on the opposite side. So this is one of the products. Maybe you didn't want to draw it like this. Maybe you put the bromide at the top pointing to the back and the one at the bottom pointing to the front. Right now we don't know what these are, but in the next chapter that we cover, we will actually see the relationship between these two. Alright, so when you use chloroform or when you use dichloromethane, which is also called methylene chloride, or when you use carbon tetrachloride, all these solvents right here will allow you to add the two halides across from the double bond. This reaction is different because when we do this reaction, we're going to end up with a bromide on one carbon and an OH on the other. So we're using water as a solvent. So that means the water is in really big amounts in there. And the water is going to open the bromonium ion. Now you should practice the mechanism of this reaction. But I'm going to draw the intermediate of it. The intermediate is a little three-member ring. I'm going to put it to the back. You could put it to the front if you want to, but notice that it resembles an epoxide, but I have a bromide there. So it's a little three-member ring and it has a lot of angle strain. There's a methyl on the double bond. You see, if you put the bromide to the back, go ahead and put the methyl to the front. Each carbon is going to have two straight lines, a wedge, and a dash. So we put the methyl on the opposite side. This is the bromonium ion intermediate. And it's common for the top reaction and the bottom reaction. In the top reaction, the second halide attacked and opened the bromonium ion. And that particular attack is what I like to say back attack. It's a back side attack. If the halide on the bromonium ion is in the back, the second halide will come from the top. Now when you have water, water will attack the bromonium ion. And when water attacks the bromonium ion, it's going to follow two rules. The first one is the back attack rule. It will attack opposite the halide. So my bromonium is in the back. My water is going to attack from the front. And if it attacks from the front, I want to see that OH on the wedge. The second rule is that it will attack the more substituted carbon. So this carbon at the bottom is attached to two carbons, so it's a secondary carbon. The carbon at the top is attached to 1, 2, 3 carbons. So the carbon at the top is a tertiary carbon. That's where the water is going to attack. So let me put a little molecule of water here. Now the water is going to come opposite of my bromonium ion. I put the bromonium ion in the back. That means that water has to come from the front, from the top of the page. And if it comes from the top of the page, then put the water on the front of the page. When it attacked, the bromonium ion, the little 3-member ring, popped open. So we broke this bond right here, and we gave the electrons to the most electronegative element, which was already there, the bromine. Now notice that we break this bond, but this bond at the bottom is going to remain intact. So that bromide was pointing to the back, and I didn't touch it, so it's going to remain in the back. One more thing, the methyl right here. You see the methyl moved to make space for the water that was coming from the front. So little by little, that methyl was moving to the back and the back and the back. And eventually, when the reaction's finished, the methyl will be completely in the back. What you're going to be looking for in the top reaction right here is that your halides were trans to each other. On this reaction, the OH and the bromide, those need to be trans to each other because this is an anti-addition.